Uh, actually, yesterday somehow this topic is almost relevant to our yesterday's topic. So, yesterday we discussed about the hazardous materials present in the soil, water, and how to recover make the water into potable. And we also discussed about sewage wastewater and sewage wastewater treatment. Along with that, um, here a landfill is an engineered method for land disposal of solid and hazardous waste material. Landfilling is a term, the term landfilling is used to describe the process by which solid waste is placed in the landfill, and landfills for individual waste constituents such as combustion ash, asbestos layer, asbestos, and other similar wastes are known as monophils. Here, this indicating that the chemical waste after the combustion ash and asbestos and other similar wastes are considered like monophils. And when coming to the landfills for the disposal of hazardous waste are called secure landfills. Usually, the term landfill is an engineered method for land disposal of solid and hazardous waste. And landfill is the term which is describes the process by which solid waste is placed in the landfill. Here, here you can see the presence of landfills, like see. Here it is a modern landfill design, and this design explains us about the landfill is need not be an engineered site when the waste is mostly inert at final disposal. In rural areas, a rural area waste containing a large proportion of soil and dirt. Mostly in case of rural areas, the waste which containing mostly the large portion of the soil and the dirt. The practice of disposal of such waste is called as non-engineered disposable method. Here you can see the presence of, here we can consider this as a modern landfill. In the upper layer, here the presence of the clay and synthetic cap with vegetation and the granular drainage material and the moisture barrier layer, and landfill with gas to flame a station or to energy utilization plants. What is the basic principle of this landfilling purpose? What is the principle behind this one? Means the purpose of landfilling is to bury or to alter the chemical composition of the waste so that they do not pose any threat to environment, public health. Landfills are usually made up of cells in which a discrete volume of waste is kept isolated from the adjacent waste cells by a suitable barrier. The term cell means, here that cell means a cell is used to describe the volume of material placed in a landfill during an operating period. Here we have one more a diagrammatic representation to see the landfill. This is the landfill design. Here you can see, we can consider this like a cross section. The daily cover, no landfill refuse is left exposed overnight at the land of the each day. We can see like if we will find any bare land beside to our home also, usually it's like a human tendency to throw the household waste in that land. So eventually that land becomes like a landfill. So it becomes like a landfill design. So the basic part, the uttermost part is clay barrier, which prevents the soil and the water contamination, and plastic liner, and the leather collection, and the refuse cell, and daily cover. This is finding you the landfill design. And when coming to the modern landfill design, here you can see the modern landfill. Here the well to monitor groundwater. This is the aquifer, and a trash, a methane gas recover system, and a clay cap, and leachate collection system. The landfill liner here, and leachate treatment system. Once the combustion happens, the waste material or methane gas is recovered from that system, and that will be collected. What are the basic characteristics of the landfills? The landfills, the solid waste is placed in a suitable, selected, and prepared landfill site is a carefully prescribed manner. The waste material is spread out and compacted with appropriate heavy machinery. The waste is covered each day with a layer of compact soil. Most important feature of a modern sanitary landfill design is the technology used to prevent groundwater pollution. Mostly, this is the technology which is used to prevent the pollution of groundwater. It relies on containment rather than treatment. So, what are the basic requirements for a landfill? Here, the first and foremost requirement, actually we have four minimum requirements for landfilling or landfill: a full or partial hydrological isolation, a formal engineering, a preparation, and permanent control, planned waste placement, and covering. So, for fulfilling all these requirements, we have the important aspects of landfilling processes are the feasibility of land disposal of solid waste depending upon the factors like type of solid waste, quantity of waste, characteristics of waste, and laws and regulations related with these, soil and site characteristics, total capacity and design life of a new landfill depending upon the size, a topography of the site, and rate of refuse generations, and the degree of refuse compaction. Usually, the amount of daily soil covers adds 20% of the overall fill volume. It must be considered for evaluation of capacity of landfill. For this, for maintaining all this, first we have to select the site. For the site selection process, what we need? For the site selection process, we need the suitability of a landfill site is determined by its size, area volume, technical and environmental factor, climate and hydrological conditions. It requires a development of a work plan, description of site, location, operation, and engineering work and site restoration. Usually, people are reluctant to allow the construction of a new landfill. Thus, a siting approval authority is more important. Sometimes, around the landfill, sometimes we can see the um releasing of harsh gases also takes place. Then, for this, Uh, the motto of landfilling is the protection of groundwater. So that for the site selection process and for the component process and for the cell selection and cell necessary in the landfill, everything is more important. Yesterday we discussed about the sewage wastewater. So here, after the site selection process, first we have to check the components of the landfill. What are the components of the landfill? Here, an environmental sound landfill comprises an appropriate liners for protection of groundwater, runoff controls, leachate collection and treatment system, a monitoring wells, appropriate final cover design. So here you can see the the design of landfill. Already we have seen again that could not the landfill could not disturb the groundwater. The motto of us is a protection of groundwater. That's what. So the final layer and the leachate collection layer and the leachate collection pipe. Here you can see the presence of waste and the clay liner also will be there. And here we can monitor the well, that pit or the cell. So here we can see the topsoil and drainage layer, liner, and a fill. This is all about landfill components. So what are they? Runoff controls, leachate collection and treatment system, and monitor wells. Here you can see the monitor wells and appropriate final cover design. When coming to the why the cell is necessary in landfill. The cell includes sewage waste are deposited and the daily covered material surrounding it. So the daily cover usually consisting of a 6 to 12 inches of a native soil or alternative material such as compost, sand, auto shredder, fluff. And the barriers between the cells, like soil and compost, restricts the downward or lateral escape of the waste constituents. These are the landfill cells. Here, solid waste placement and the completion, unloading of the solid waste, and spreading into thin layers, compact solid waste, and the completed landfill cells. Every cell is considered like a landfill. And landfill design and operation. Here, the planning phase that involves a preliminary hydrogeological and geotechnical site investigation as the basis for actual design. And the second one is the construction phase. Here, the construction phase that the earthwork, here you can see clearly, earthwork, road and facility construction and preparation, liners, drawings of the fill area. The next one is here, you can see the operation phase, which takes up to 5 to 20 years, that involves a work at the front of the fill area and the operation of environmental installations and completion of finished sessions has a high traffic intensity. A completed phase in the phase of 20 to 100 years, it involves the termination of actual filling to the time when the environment installations need no longer to be operated. The emission may be decreased to a level where they do not need any further treatment and can be discharged freely into the surroundings. Final storage phase. In this phase, the landfill is integrated into the surroundings for the further purpose. No longer needs special attention is needed. So that here you can see the final cover or cap specification. Before that, here you can see the picture which depicts as the landfills. And final cover or cap specifications. The final cover, once the landfill reaches design height or a final cap is placed to minimize infiltration of rainwater, minimize dispersal of waste, and accommodate settling or facilitate long-term maintenance of the landfill. Here you can see the complete structure of landfill. The final cover shall have a barrier soil layer. On the top of a barrier soil layer, there shall be a drainage layer of 15 centimeters. Here, 15 centimeters. On the top of drainage, there shall be a vegetative layer of 45 centimeters to support natural plant growth and to minimize soil erosion. And final cap specifications. A cap consisting of from top to bottom and vegetation and supporting soil is 6 inches. Filter and drainage layer a protective material 18 to 36 inches drainage material, and the drainage material is of 12 inches, a hydraulic barrier uh, clay 24 inches, and LDPE that is of 4 inches, and gravel layer with 6 inches. Sand bed, the sand for the sand bedding, LDPE is 4 inches. What are the specifications for landfilling operation? A waste subject to landfilling shall be compacted in thin layers by compactors to achieve high density of the waste. Prior to the commencement of monsoon season, an immediate cover of 40 to 65 centimeters thick of soil shall be placed on the landfill with the proper compaction and grading of prevent infiltration. A proper drainage shall be constructed to divert the runoff away from the active cell of the landfill. When the total depth of the landfill exceeds 9 meters, that is 30 feet from the base, an intermediate cover to be used at medium depth. It is typically 2 feet of clay soil and 6 inches of topsoil over the area. And the new phases are started on the top of the lower phase. And landfilling, a settling process. This landfilling settling process here it consisting of 3 stages. One is a primary consolidation, and the other one is secondary compression, and third one is decomposition. When coming to the primary consolidation, a substantial amount of settling occurs at this stage. It is caused by weight of waste layers and the truck movements and bulldozers and mechanical compactors. After this stage, aerobic degradation of the waste products may be occur. A secondary compression, a rate of settling is much lower than the first stage. Settling occurs through a compression. When coming to the decomposition, it is the degradation process. The organic material is converted to gas and leachates, means acids and alcohols, leachates. A settling rate increases as compared to a secondary state, but with the passage of time, it gradually decreases. It continues till the organic matter is degraded. The other one is the microbial degradation process. The microbial degradation process, in the microbial degradation process, the biological process, it is a biological process in which most important aspect of landfilling which determines the quantity and quality of leachate and gas. After the disposal, large part of waste becomes anaerobic due to the absence of oxygen. A microbial activity degrade the the solid organic carbon and produces methane and carbon dioxide. In an anaerobic process, a solid and dissolved organic compounds are hydrolyzed and fermented to volatile fatty acids, alcohols, hydrogen, and carbon dioxide. The methanogenic bacteria, which convert the acetic acid to methane and carbon dioxide. And hydrogen philic bacteria that can convert the hydrogen and carbon dioxide to the methane. So this is how the microbial degradation process taken place. Here you can see the pathways for common organic waste materials. If the waste material contains protein, a protein is converted into amino acid, and the amino acid is converted to hydrogen or carbon dioxide and methane. And if the waste material contains the carbohydrate, that converted into simple sugar with the help of microorganisms, and that will be in turn converted into acetate, the final product of um, this waste material is again methane and carbon dioxide. If the waste material is a lipid, the lipid is a long chain of volatile fatty acids. That volatile fatty acid becomes like a short chain of a volatile fatty acids that produces acetate. So here the final product of the waste material, final decomposition of the common organic waste material is a methane and CO2 and acetate. Then here, what is the composition of landfill gas? Here you can see the gases like methane 45 to 60%, carbon dioxide 40 to 60%, nitrogen 2 to 5, ammonia 0.1 to 1, and oxygen 0.1 to 1, hydrogen 0.2, sometimes nil also there, and carbon dioxide 0 to 0.2. Then what are the factors affecting the landfill gas and the leachate generation? What? Here, the nature of waste, moisture content, pH, particle size and density and temperature. Nature of waste, amount of gas mostly depending upon the content of biodegradable material in the waste. The moisture of the content, microorganisms require minimum 12% of moisture for growth. Thus, it is an important factor in determining the gas production. pH, methanogens grow only at low pH around neutrality, like 7. The percentage of gas depending upon the pH. Particle size and density. A particle size affects the density achieved by compaction and affects a surface area and volume. This affects the moisture absorption and thus the biological degradation. And the other one is temperature. A temperature increase in temperature tends to increase in increase in gas production. It affects microbial. It in turn affects on the microbial activity. What are the methods of landfilling? Landfilling methods. Here we have the principal methods used for landfilling are excavated, cell and trench method, ideally suited to areas where an adequate depth of cover material is available at the site and water table is not near the surface. Mostly if If we are thinking to construct a landfill, the first and foremost thing we have to see, the area should be suitable where an adequate depth of cover material is available. The site and the water table is not near the surface. Sewage water are placed in cells or trenches excavated in soil. Soil excavated from the site is used for daily and final cover. Excavated cells are lined with a synthetic membrane liners, low permeability clay, a combination of two, or limited the movement of landfill gas and leachate. This is about the first principle, like excavated cell or trench method. When coming to the next method, that is area method. In this area method, which is used when terrain is unsuitable for excavation of cells or trenches and groundwater table is very high, then we can use this area method. In this area method, we have to see, first we have to glance the site preparation includes installation of liners and leachate management system. And cover material must be obtained from adjacent land, burrow pit areas. Since there is a limited material for covering, compost and foundry sand has been utilized as intermediate cover material. Temporary cover material of the soil and the geosynthetic blankets placed temporarily over completed cell and removed before next lift is began. Leachate generation may occur and may be difficult to control. The third one is canyon depression method. Before going to the canyon depression method, here I want to show you the trench method and the area method picture. Here you can see the first method, trench method, and the area method, landfilling method. Here you can differentiate easily after seeing the pictures of trench method and the area method. The basic difference of the trench method, that is excavated cell method, is first we have to see the water table, the site and the water table is not near the surface. Okay. Then a sewage water are placed in cells, trenches excavated in the soil. The soil excavated from the site used for daily and final cover. The excavated cells are lined with synthetic membrane liners, a low permeability clay combination of two to limit the movement of landfill gas. When coming to the area method, here the main thing is when the this method is used when terrain is unsuitable for excavation of cells or trenches and the groundwater table is very high, which is near to the site, then we have to prepare the site includes installation of liners and leachate management. So the cover material must be obtained from the adjacent land, burrow, pit areas. Here you can see clearly in this picture. So the third method is canyon or depression method. What is canyon and depression method? So, this this method is involves a placement and compaction of sewage water in canyon depression. It differs with the geometry of site, characteristics of available cover material, hydrology, geology of the site. A control of surface drainage is often a critical factor in this method. Here the filling starts at the head of canyon and ends at the mouth to prevent accumulation of the water behind the landfill. Here we have some advantages of the landfilling. What are the main advantages of the landfilling here is in addition to provide an option for the waste management, it also serves to improve or reclaim poor quality land. It raises the ground elevation or surface grade of the site. A completed landfills have been converted to municipal parks, playgrounds, courses, and community land use projects. It is the most economical alternative for sewage waste disposable, which accounts for its frequent application. Other disposable methods are not entirely safe and efficient throughout the year. Incineration is a costly process. A residue requires ultimate disposable on land. A composting is the seasonal option. It is not possible to reclaim and recycle all sewage waste material. Thus, landfilling is the most convenient option. When coming to the disadvantages, the most and foremost disadvantage is damage to the local system. Seriously, it damages the local system and difficult to find suitable site within economically feasible distance. It is not possible to build a completely safe and secure sewage waste landfill. Some of the pollutants may escape in environment in the form of leachates. So the potential harm to public health are due to air, soil, water, and noise pollution. Damage to local ecosystem, and that leads to public oppose. So here we have to see the public and environmental health concerns before we are going to start any landfill. So it is very important to minimize the contamination from landfills to the surrounding environment and hydrology, groundwater flow, geology, the rock type and soil permeability of the site has a direct influence on the possibility of water pollution. That is ground level water table or groundwater pollution. The landfill should not be located in low-lying wetland areas. Those are near marshes, swamps, as the waste should not come in contact with the surface or with the groundwater. It should not be located in floodplains of streams like rivers, and there should be a minimum distance of 60 meters from any lake or pond. Like the vertical separation of 1.5 meters between base of landfill and seasonally high uh, groundwater table elevation. It should not be located in unsuitable areas, or if it is presented, it must be designed to resist forces caused by seismic activity. Uh, this is about the landfilling. In our syllabi, we have this landfilling, though the final and um, the final thing, the final summary is like here the landfill is an engineered method for a land disposable or a land which is used for the disposal disposable disposal sorry disposal of solid and hazardous waste, that is sewage waste. And landfill is a term which is used to describe the process by which solid waste is placed in the landfill. And landfills for the individual waste constituents such as combustion ash and asbestos and other similar wastes are known as monofills, and the landfills for the disposal of hazardous waste, mainly for hazardous waste, are called a secured landfills. This is about landfills. And what is the major principle for this landfills is here the purpose of landfills is to bury, alter the chemical composition of the waste material or the sewage waste or industrial waste or solid waste, so that they do not pose any threat to the environment. To avoid the threat to the environment and the public health, we need to purpose the landfills. So landfills are usually made up of the cells and which a discrete volume of waste is kept isolated from the adjacent waste cells by a suitable barrier. This is about the landfills, and the term cell is used to describe the volume of material placed in the landfills during the one operating period. Later, we can convert these landfills uh, as a once the landfill time tenure is over, we can make it as a park for playgrounds and the golf courses and the community land use process projects. Then we can use that, we can convert the ground landfills into best environment, suitable environment for the convenient. This is the convenient option for the composting of disposable. This is about landfilling. The other thing or the next topic, our next topic is composting. Composting. Okay. So our next topic is composting. Name itself indicating the composting. It is a process of a, um, a controlled decomposition. Before going to describe about the composting, even yesterday or today, we discussed about the municipal solid waste. The organic content of the municipal solid waste that tends to decompose, leading to various smell and odor problems. So, it also leads to the pollution of the environment. To ensure a safe disposal of the municipal solid waste, it is desirable to reduce its pollution potential, and several processing methods are proposed for this purpose. The first thing is composting. A composting is a quite commonly used and results in production of a stable product, a compost which depending upon its quality can be used as a low grade manure and soil conditioner. The process results in conversion of the process involves the conversion of a natural resources, and it is an important processing method, especially in agriculture and horticulture areas. In the case of individual households, a small establishments and in colonies, the vermicomposting, which involves the stabilization of the organic solid waste through earthworm composition for conversion of the organic material to worm casting. We will discuss about this casting in our next discussion. This worm casting is being increasingly preferred. So, here, what are the principles of composting manual and mechanized methods? So, the composting, decomposition, and stabilization of organic waste material is a natural phenomena. Composting is an organized method of producing compost manure by adopting this natural phenomena. Compost is particularly useful as an organic manure which contains a plant nutrients like a nitrogen, a phosphorus, potassium, as well as a micronutrients which can be utilized for the growth of plants. When used in conjunction with the chemical fertilizers, optimum results are obtained. Composting can be carried out in two ways. One is aerobically and anaerobically. During aerobic composting, aerobic microorganisms oxidized organic compounds to carbon dioxide, nitrate and nitrates, nitrite and nitrates, and carbon from organic compounds is used as a source of energy, while nitrogen is recycled due to the exothermic reaction. The temperature of the mass rises during the anaerobic process. The anaerobic microorganisms, while metabolizing the nutrients, break down the organic compounds through the process of reduction, a very small amount of energy is released during this process. The temperature of composting mass does not raise much. The gases evolved the gases which evolved mainly like methane, carbon dioxide. An anaerobic process is there is a reduction process, and the final product is subjected to some minor oxidation when applied to the land. Here, what are the basic benefits of composting? Like benefits of composting or the real economic benefits of composting, that includes a soil quality, enhanced water retention capacity of soil, increasing that increased the biological activity, micronutrient content, and improved pest resistant of the crops. And composting minimizes that avoids GHG emissions and anaerobic decomposition of organic waste such as large unturned heap. The composting increase the design life of the waste management facilities. The stringent design requirements and associated cost for catering to the management to the leachate from organic waste, a decomposition may be reduced in those landfills that do not receive organic waste. The use of compost reduces the dependence on chemical fertilizers for agricultural operations. What are the constraints faced by the composting sector in India? Actually, we have the different methods of composting. One is indoor method and another one is Bangalore method. The manual decomposition was systemized by the scientist Howard and his co-workers. It was further developed by the Acharya and Subramanian, and the method are conventionally referred as indoor and Bangalore methods of composting. In case of Bangalore method, this is an anaerobic method conventionally carried out in pits. Formerly, the waste was anaerobically stabilized in pits where alternative layers of municipal sewage material and night soil was laid. So this is also one method of municipal solid waste management concept, and the material is allowed to decompose for 4 to 6 months, after which the stabilized material is taken out and used as compost. Another method, that is indoor method. In this method, in pits, involves filling of alternative layers of similar thickness as in Bangalore method. However, to ensure aerobic conditions, the material is turned at specific intervals for which 60 centimeter stripe on the longitudinal side of the pit is kept vacant for starting the turning operation. The first, a turn in manually given using long-handed handled racks with 4 to 7 days after filling. The second turn is given after 5 to 10 more days. Further turning is normally not required and the compost is ready within 2 to 4 weeks. In the urban areas, due to excessive provision of water carrier system of sanitation and night soil is not available, then the composition of municipal sewage waste alone is hence often carried out. Aerobic composting of municipal solid waste, municipal solid waste is commonly carried out in windrows. A comparison of these two methods, the Mangalore method requires longer time for stabilization of material and hence needs large land space which is in short supply in urban areas. The gases generated in this anaerobic process also pose smell and odor problems. The indoor method on other method stabilizes the material in shorter time and needs a lesser land space as no odors, gases are generated in this process. It is environmentally friendly, hence commonly preferred one. While the organic material matter is stabilized during the composting processes, the moisture content also changes. The non-decomposables are also rejected. Hence, the quality of compost is much lesser than the input. And it is normally around 50% and the exact value depending upon the characteristics of the input material. When coming to the windrow composting, the organic material present in municipal waste can be converted into a stable mass by aerobic decomposition. Aerobic microorganisms oxidized organic compounds to carbon dioxide and oxides of nitrogen and carbon from organic compounds is used as a source of energy. While nitrogen is recycled due to exothermic reactions, a temperature of mass rises in areas or the regions where the high ambient temperatures are available. A composting is open windrows is to be preferred. In this method, a refuse is delivered on the paved or unpaved open spaces, but level and well-drained land in about 20 windrows, in which each windrow with 3 meter long and 2 meter wide and 1.5 meter height with a total volume of which not exceeded up to 9. Each windrow would be turned on 6th and 11th days outside to the center to destroy insect larvae and to provide aeration. On 16th day, windrow would be broken down and passed through manually operated rotary screen of about 25 millimeter square mesh to remove the oversized contrary material. The screened compost is stored for about 30 days in heaps about 2 meter wide and 1.5 meter height and up to 20 meter long to ensure a stabilization before sale. And the constraint faced by the composting sector in India. Our composting quality standards are becoming increasingly stringent. Majority of the collection of municipal solid waste is in the form of mixed waste, making quality complaint compost from mixed waste requires some equipment for refinement and quality control and high production cost, but the yield reduced as the quality standards are 10 to 15%. All compost sold for the application to crops is mandated to be FCO compliant. A percentage of process rejects increases proportionally unless the processing facility produces a compost as well as a refuse derived fuel. The lack of knowledge is main um, and a practical experience, a lack of knowledge and practical experience among the various stakeholders responsible for the planning, execution, operation, and maintenance. And marketing leads to the inadequacy, design plans, inefficient equipment, improper operation, and shortcuts from the equipment design to operation protocol. After the protocol is ready, called a finished compost, the cost is about incurred for bagging, transport, marketing, and commission of the chemical fertilizer company with the dealers, etc. The final cost to the farmer is normally almost twice the price received by the compost plant operator. As of now, in 2015, the total cost to the farmer is about 4,000 to 5,000 per ton of finished compost, the distance being the main price variant. This price is too high for the average farmer. These are the limitations of um, constraints faced by the composting sectors in India. Along with this, we have the factors which affecting the composting processes, organisms. Organisms and the use of cultures, moisture, temperature, and carbon nitrogen ratio, and mainly the destruction of some common parasites and pathogens taken place at the end of the composition, and aeration and addition of sewage and sewage sludge taken place. So the first limiting factor here is organisms. The organisms, aerobic composting is a dynamic process where the bacteria and actinomycetes, fungi, and other biological forms are actively involved, and the use of cultures. During the development of composting process, various innovators came forward with inoculum enzymes acclaimed to hasten the composting process. Investigations carried out by various workers have shown that they are not necessary. And when coming to the moisture tends to occupy the free air a space between the particles. Hence, when the moisture content is very high, aerobic conditions set in. And temperature, the aerobic decomposition of a gram mole of glucose releases 486 no, sorry, 484 to 474 kilocalories of energy under controlled conditions, while only 26 kilocalories are released when it is decomposed anaerobically. Municipal solid waste is known to have good insulation properties, and hence the released heat results in increase in temperature of the decomposing mass. Not only this, we have carbon nitrogen ratio. The organism involved in stabilization of organic material matter utilized about 30 parts of the carbon for each part of the nitrogen, and hence an initial carbon nitrogen ratio of 30 is most favorable for composting. Research workers have reported the optimum value for ranging from 26 to 31 depending upon the other environmental conditions. The carbon nitrogen ratio considers the available carbon as well as available nitrogen. So with this, I want to discuss about the properties of here we discussed biological process and the chemical parameters and the physical parameters like temperature, particle size, everything we discussed. And the other thing is properties of compost. Here the properties of compost is prepared from municipal solid waste should be black brown, at least black in color. It should be crumbly in nature with an earthy odor. The pH should be uh, slightly acidic or alkaline pH within the range of 6.5 to 7.5 can be tolerated. The compost should neither be completely dry nor it be lumpy, and water should not come out of the mass when squeezed. The nitrogen, phosphorus and potassium contents should be more than 1% each, and carbon nitrogen ratio should be 15 to 20. In order to ensure safe application of compost, the standards laid down in the draft of municipal uh, waste management handling rules 1999 that notified in 27th September 1999 by the Ministry of Environment and Forest, Government of India, for the production of compost is arsenic 20. 20 means maximum acceptability concentration parts per million ppm, parts per million. Arsenic 20, cadmium 20, chromium 300, copper 500, and lead 500, and mercury 10, nickel 100, zinc 2500. Here we have the mechanical composting process. It is the cheap and cheap. It is preferable in the countries where labor is comparatively very cheap, and mechanical process are preferred where high labor costs and limitations of the space exist. The first full-scale plant was established in 1932 in Netherlands by a non-profit utility company, that is WAM, using the Van Manen process. It is not vascular avascular mycorrhizae, in which raw refuse is composted in large windrows which are turned in intervals, mobile cranes moving on the rails. Uh, Several other methods, processes were subsequently developed using the different methods of processing. A solid waste using different designs of digester, like a unit process. It is a mechanical composting plant in the combination of various units which perform specific functions. And the composting plants for Indian municipal solid waste is first we have to assess and development of market. A selection of sites is more important, and leachate management is more important. And after the selection site, we have to do some pilot studies. We have to make some flow charts. We have to see the environmental control for less than 1 lakh population. We have to see the flow charts, and more than 5 lakhs population also we have to check the flow charts. And with this, I'm going to vermicomposting. Vermicomposting is the next chapter. Uh, Earthworms are hermaphrodites. We Each worm has both male and female organs. They are small tube-like organisms who tirelessly work to turn the earth from lowest strata of earth to the top. A worm's tunnel deeply in the soil, deeply in the soil and brings subsoil closer to the surface, mixing it with the topsoil. This makes the formation of multitude of linear tunnels, minute in diameter but deeper below the subsurface. These tunnels last long even after the worms are dead. These tunnels facilitate infiltration of water into subsurface, reduce runoff, and help in harvesting the rainwater. Such stored moisture is slowly released to crop at summer season. In this process of tunneling, it also maintains the soil structure and enables the process of aeration. This is the act made by the earthworm as a real farmer who toils day long, tiling throughout the year. So we can consider the earthworms are the friends of farmers. And in the field of organic cultivation, we could see the reserve moisture through the year. The latent hard work of a large number of worms helps the crop survive when other areas are parched. Here, earthworm live on, we can call waste. Yes, they feed on the vegetable waste. We throw leaves shed from trees and any form of organic matter available in the soil and living organisms such as nematodes, protozoans, rotifiers, bacteria, fungi, which are harmful to plant growth. Their intake per day is one third of their body weight. The organic matter the earthworms consume gets digested in their bodies and gets excreted and in the form of gas. A type of soil aggregate rich in nutrition. Does earthworm facilitate improving the fertility and deposits on the surface their whole grain? The main role of the earthworms that gains significance mainly because of the they convert a larger organic material into a simple accessible form. Here I want to show you the structure of earthworm. Everyone knows this earthworm. So, which is belongs to the systematic position, which is belongs to Annelida, Oligocete, class Oligoceta, genus Peritima, species Postuma. As just we discussed, it is a nocturnal in habit and live in damp, moist humus, humus-rich soil of lawns and gardens. And their niche is herbivore and macro decomposer and is important as a source of food for birds. It also helps in soil aeration and increasing soil fertility. The external characters: a body is long, narrow, and cylindrical. A length may reach up to 150 millimeter. Body color is brown. Anterior end is pointed while the posterior end is blunt. Body is divided into 100 to 140 segments called metameres, and the anterior most segment is called prostomium. And the mouth is, we already know the structure of uh, this peritima. So I want to skip this peritima structure. So no need of going with, I guess no need of going with the digestive system, everything else. So the main, our concentration is concentrating on the vermicomposting. This tells us the complete structure, excretory system of earthworms. So no need of going with all this. So firstly, our concentration is the economic importance, that is how to make the composting. Solid waste is the one of the environmental challenges facing the world today due to increasing population and urbanization. Composting is a natural process of organic waste treatment, which is currently practiced with various modification to the technology. So here we have the Vermi technology. Vermi technology is globally becoming a popular solid waste management technique. Vermi technology is a process by which the bioconversion of organic waste into a biofertilizers due to earthworms activity. The earthworms feed on the organic waste and the earthworm's gut acts as a bioreactor whereby vermicast are produced. So here, um, organic waste, animal manure, crop residue, sugarcane trash, vegetable fruit residue, leaf litter, food waste, any biodegradable waste, all these we can consider like a organic waste. So types of earthworms used for composting. This is main important. Anistic earthworms feed on decaying organic matters which are responsible for cycling organic debris into humus, and endogic, these worms are spending their lives deep in the soil where they feed on decayed matter and mineral soil particles. Those worms build burrows, and epigetic species, these are found in natural environment in the topsoil layer where they feed on decaying organic matter. Uh, these are the species used for the culture, that is Lampito, Moriti, and Perionetsi and excavators. This is the life cycle that you know, obviously. Where I can do composting means in the pits, crates, tanks, and concrete rings or any containers. Here you can see all these like pits, crates, and tanks, and concrete rings also here. Significance of vermicomposting is a low cost technology used to treat organic waste. It stimulates plant growth and productivity of soil. It also has positive effects on some aromatic and medicinal plants, and it can act as a good soil conditioner, and vermicompost significantly reduce or even replace the use of dangerous agrochemicals. Then it develops the economy and ecology of the nation. So the benefits of learning that this technology, you can make use of vermicompost to make your own terrace garden, kitchen, and home garden. Here you can see.